Welcome back again to Apache Kafka series. Next, we will also look into tracking offset. What does this mean? For example, you normally have your messages. So we have said before, we have messages, and in each message, we also have offset. This message offset being tracked. Unlike other messaging systems, Kafka does not track acknowledgement from consumers. So consumers use Kafka to track their position or offset in each partition. So when a consumer consumes message, then it also send an update to Kafka like this message I have consumed and processed it, and this update will be committed or will be saved in a different topic. The name of the topic is __consumer_offsets, and then this topic is used to commit the offset for each partition. So this is the way that the consumer keeps track of the messages it processes. Kafka does not keep track of the acknowledgement. So another thing, what might happen, for example, due to some scenario or due to some cases, like in cases of rebalance, what might go wrong? Assuming we have a consumer, or assuming a consumer has consumed some messages, like we have in the diagram here, the consumer has consumed some messages, but before it commits the offset, this is the message it's committed previously that I have processed offset 0. Then it polled for more messages. Then when it polled for more messages, it got 1, 2, 3. Now, let's say you are writing these messages to database and committing the transaction. Then now you are, the consumer is processing the third one, or 3. Therefore, due to some issue, then the consumer just shuts down. When the consumer shuts down, what will happen? Rebalance will happen. And when rebalance happens, this partition might be assigned to, or will be assigned to, a different consumer because this consumer is down. So because this third message is not committed yet, or the offset is not committed, when another consumer gets this partition to process, when it goes to get the committed offset, this consumer will get 0. That, oh, okay, 0 is committed. That means I should start processing from 1 again. But previously, the previous consumer has processed 1, 2, and it is now in 3. Maybe it has even committed these messages to database. So what will happen now? If another consumer got the same partition and start processing again from 1 to 3, then what will happen? We will have duplicate messages. So these are kind of thing also we have to put into consideration while configuring Kafka. Then another scenario also, we can have, or we can miss messages. Okay, how does that also work? And the same scenario that we used before, now assuming the first, or 0, is been committed, then it got 1, 2, 3. Now our consumer has processed the first one, or number 1, is now processing number 2. But due to some configuration, also this consumer has committed offset 3. Like, okay, I have processed it, because sometimes if you use automatic offset commit, then let's say it's 5 milliseconds, and this processing took longer than expected. So after that 5 milliseconds, it sends commits, the third that was taken is being committed. But the consumer behind the scene is still processing the second offset. So now, while the consumer is processing the second offset, if anything happens and the consumer fails or shuts down, what will happen? Committed 3. The third one, or the number 3, is being committed, but it is processing number 2, but now it is down, and rebalance happens. And then when rebalance happens, this partition is then assigned to another consumer. When the consumer checked which partition is being processed or is being committed, it will get number 3, and it will start processing from 4, 5, 6. And in this case, we missed partition or offset 2 and offset 3 because this have the previous consumer haven't finished processing this messages. So in this kind of scenario also we can have or we can miss messages. Then next we are also going to look into config properties of the consumer. Below is the documentation of the Apache Kafka consumer documentation. From this documentation you will have a lot of properties, their explanations, and how to configure them. But for now, let's say for example we already know Bootstrap server. We know that the Bootstrap server just holds a list of our broker addresses where the consumer will connect to, and we also have a key deserializer. In the previous video we have seen key serializer. Now here we have key deserializer, which deserialize the byte array, the key byte array, to the, let's say if you are using string, to the string or to whatever object you are using. We also have a value deserializer, which deserialize the byte array, the message byte array, into an object or whatever object you are sending to Kafka. Then next we also have group ID. The group ID specifies the consumer group. Which group does this consumer belongs to? So there you give a string value, and all the consumers with the same string value will belongs to the same group. And we also have a session timeout in milliseconds. The default is 10 milliseconds. A time a consumer can take without sending any heartbeat. Previously we talked about heartbeat. So this is how long a consumer can take. By default is 10 milliseconds. A consumer can take without sending any heartbeat to the group coordinator, and still the group coordinator will consider that consumer as being alive. Then we also have request timeout millisecond. This is the time a consumer can wait for a response from the broker. So from the Kafka broker. So the default is 30 seconds. When a consumer sends a poll to get messages, it will wait up to 30 seconds. So if nothing from the broker, then the consumer will close the connection and it will try connecting again. Then we also have the auto offset reset. With auto offset reset, if consumer doesn't have committed offset, or for example, due to some rebalance issue, let's say as we give in the previous scenario, a consumer is consuming a partition, then the consumer is reading, let's say, processing offset 3, then the consumer is down or failed or shut down. Then rebalance happens and this partition is now assigned to another consumer, and that consumer continue processing that partition. Now let's say after 5 seconds again, or after 5 minutes, the second consumer also, let's say, shut down, and the first consumer is back. So now when the first consumer is back, and if luckily that the same partition is assigned to the first consumer, so let's say it is static consumer, and now it is back, and then the partition that it was processing before was now assigned to it again. Then because the previous offset, now the static consumer has the previous offset. When it tries to get or to poll for messages, then this offset is invalid because someone has, or another consumer has processed it already before. So because of this, the consumer can get an error, invalid offset. So it has almost 3 properties that you can use any of them. And number 1, when this error happens, or when this exception happens, what should happen? You can set it to latest. This means that when the offset is invalid, then start consuming from the latest messages, from the current messages. From the current message, start processing from there. Or you can also set it to earliest. If you set it to earliest, then when this exception, when the consumer got this exception, then it will reset and then start consuming from the beginning. Or you can set it to none. When you got this, then the end of it is just an exception. So, and then we also have the group instance ID. We have talked about this already. The group instance ID used for Kafka static group membership. So if you gave this or if you set this property to a consumer, then that consumer will be considered as a static member. So these are like the internals of how consumer clients work. Also, for more details and information, you can go through the documentations. In the next video, we are going to continue with writing code with Java as usual, Spring Boot and Spring Kafka library. We will write a consumer that will listen to a message sent by the producer we wrote before, and then it will consume those messages, and then we will see how it works. So until then, I hope it will benefit someone out there. We will continue in the next video.